Hi everyone, in this video we'll talk about the temporal tables, which is a new feature in SQL Server 2016. So just to give you a brief description, um, it, the temporal table allows you to audit your detailed data on a table based on a period. A period is what you define by using two date time two columns that will define your validity period or an active period of a record. The same period can also represent or mark an historical record. We'll look into that in detail in this video. um, this feature not only allows you to audit the data but also give you a mechanism to actually query the historical and current data. So how it works is, so you have two tables. One is the actual table and one is the history table. The actual table is a table that you would like to audit. The history table is a table that the audit data gets actually saved to. So basically these two tables have similar physical design. So when you insert a data, the data goes into the actual table, but when you update or delete the particular record, the record actually goes to the historical table. So here we have the SQL Server 2016 CTP 2.0 version, and then I have the AdventureWorks database. So with this new feature, they also added new sys catalog views and also made some changes to existing catalog views. For the sys tables, they added three new columns that will add some metadata for these tables in the sys tables. So it will allow you to find out which tables are temporal tables and which tables are history tables. So in our query, we were just trying to find if there are any temporal tables in our database. So right now we don't have any temporal tables. So in this demo, I chose to audit the production.product. The reason behind is that, the goal is that we would like to audit this table and see how the list price or the standard cost is changing over the time. So we would like to audit the change of price or cost of an item. Traditionally, you would achieve the same functionality in SQL earlier versions of SQL Server using triggers, or some apps or some app code in application logic that allows you to insert this data into another table. But here we don't need all that. It's they're broken down into three simple steps. First is you select the table that you would like to audit, and second one, you define your period columns, which is two date time two columns, and then third, you enable this feature on the table to start auditing the data. So um, so if you look at the physical design of this table, it's just a simple table. It has a bunch of columns, and you can see it also has an identity column and also a couple of indexes, a clustered index. This table is organized using a clustered index, and we have bunch of foreign keys and check constraints, pretty much everything. So this is just a basic table, general table in SQL Server, nothing special. um, so so let's go ahead and now we have chosen the table that we would like to audit. Let's go ahead and define the period columns. Here there are no columns that exist in the table that I could use as a period, but rather I'm adding two new columns, the sys start time, sys end time, that will act as a validity period of a particular record. So I'm going to run this statement. So basically we are adding two columns with the date time to data types. The sys start time has a default date as the UTC date, the current UTC date time. Please note that we are not using a regular date, we are using a UTC date time, universal time. And then the sys end time will always be the max date, which is 9999, 12th December 31st. So let's go ahead and run this statement. Alright, so if you let's go ahead and look at the same table, production.product, and see how and what happened to this table. So basically we added two columns, like I just mentioned before, the sys start time and sys end time. So you can see sys start time is the current UTC date time because it is a default constraint, and sys end time is a max date time. All right. So now we selected the table that we would like to audit. We defined the period columns. Now we're going to enable this feature. The way you're going to enable this feature is a simple syntax here, and also I forgot to mention the temporal table feature is also called as system versioning in SQL Server. So we alter the production.product table and we set the system versioning on, and then we choose what the history table is. Please note that this table doesn't exist in the database as of now, but when we run this syntax, this table will get created in the database automatically by SQL Server. If it already exists, it will not, it will just enable the feature, and it will not drop the table, but it will just start auditing the data into that history table. So here our actual table is production.product and the history table is production underscore history. So please make a note of that. So let's go ahead and run this T-SQL. So that actually finished, and we enabled the temporal table feature or system versioning. So let's go ahead and look at now this table is got created in the SQL Server. Let's go ahead and take a look at how it actually looks. It pretty much looks the same as the original table, the table that we wanted to audit, but the fact that we don't have any identity column, we don't have any foreign keys, or we don't have any check constraints or default constraints. I'm sorry, yeah, and then we all we have is the primary clustered index that was there on our original table. Well, you can also add additional indexes on the history table, but you cannot have check constraints or default constraints or triggers or entity columns in your history table. SQL Server will not allow you to do that. So if you look at this history table, the data inside the table, there is no data because we just enabled this feature, and we just created this table, or if it's not, we just enable the feature. So let's go ahead and actually see, make sure the system works. Okay, now we enable the feature, let's see how it actually works. So let's go ahead and query the production.product table and let's select some rows. So in this demo, I'm going to choose the mountain seat assembly. Let's say the business had modified the price of this record. Let's go ahead and choose this record, product ID 514. Let's say the business decided to actually audit the price of this data. Let's say they wanted to see how the price has been changing over the time. So you you update the production.product table with a simple update statement with that product ID. All right, let's go ahead and run that. So we are basically updating the production.product table. Now according to our earlier discussion, this should, when you update the actual table, the historical data, the record that existed before, the price which is 133.34, should be moved to historical table. That's the idea. So let's go ahead and run this table. You can see there were 2 rows affected. So let's go ahead and query the production underscore history. So now there is 1 row for the product ID 514, which actually marks the old price. So if you look at the production, this is the production dot history. So this is the historical table. So if you look at the production dot product, which is our current table or the actual table, you can see the list price is 150. So so you are able to audit the data based on in any column. If you update any column with this feature, you can the historical data gets moved to the history table, not only just the list price, any column in this table. Yeah, so let's okay, now we saw, now we know, now we have saw how it actually works. Let's go ahead and delete the production.product. What happens if you delete the record? Will the record actually gets removed from the history table? No. So if you, let's go ahead and delete this record. The reason why it's taking is it has these cascade constraints in the other table. So yeah, so that record is deleted. But if you go ahead and look the history table, you will now see there are two rows. This is the first row that was inserted when we first updated the price. This is the second row that was inserted when we actually deleted the record. So if you look at the production.product, there will be no product because we removed it, but you can see in the history table, you know, history table to see how this record changed over the time. You can, using this start time and sys end time, now you have a good idea, you know, when this record was inserted and when was the price originally updated and when it was actually deleted. So that's, you know, that's how this entire system works. So how to actually disable this feature? Okay, now great, you know now on how to enable and how to audit the data. How to disable, you know, you just run this statement called alter production.product, which is the actual table, and then you set the versioning off. So that will actually disable your audit. So when you update or delete anything, nothing will be audited into the history table. So we are basically pausing the audit, or you know, we are just keeping it on hold. You can enable the feature back, but when you re-enable the feature, you need to point the history table, and at this time you can also change your history table again if you want. um, uh, but that, you know, results in the data consistency check. You know, the data consistency check will make sure that the historical table has integrity. That means it should not have any duplicate entries for the same start time and the same end time. So that will provide you the logically incorrect result, which is, you know, your audit will be duplicate, your audit will have duplicate results. You know, that's what you don't want when you retrieve the historical data. So to disable this feature completely and to drop the columns that we added originally, this is how you do. You're going to first of all, you're going to set the system versioning. Let's go ahead and turn on. So you're going to set the system versioning off. You're going to drop the period definition, and you truncate the table if you want. So you're going to drop these default constraints that we created for the two columns that we added for the actual table, which is production.product, and then we drop the columns, and then we drop the historical table. Alright, so that actually ends our demo of the temporal table and how to implement it. If you would like to see the introduction, that is the how it actually works, please make sure you check the other video in the section, and let me know if you have any questions or comments. Thank you for watching. Have a great day.